Okay, let's look at the bell word questions. So, what did you say for number 1? Maybe I'm going to pull 6. What did you say for number 1? Nalini. Say negative 16x. Yes, negative 16x squared, y squared. Good job.
For what? That was 8 times.
That was 8 times. Oh, did you say 16 or 64? It is 64. I'm sorry. Yep, you guys are right. Yep. So 64. Okay, and then number 2. What did you say for number 2? Aubrey.
16 and x to the power of 14.
How'd you get 14?
I added the powers together.
What did you do with the 2 and 4? Can you add those?
Well, I multiplied those and then added 8 to 5 for x.
Which is 13.
Oh.
Right. Yeah. Okay, good. So you did the steps right. You just a number off. Good. Yep. Any questions about those?
No.
Or on your homework?
No.
Okay. So today we're going to do 7.2.
I have one question.
Okay.
So I'm looking at hack and the midterm is it already average with my overall grade? Or
Okay.
Just there?
Wait, what do you mean?
My midterm is it already average with my whole grade, or is it just completely set?
You're going to have to show me. I don't know what it looks like on your end. So just ask me after we're done with this. Okay. Maybe I clicked the wrong button. There we go. All right. So now we're going to learn about quotient of powers. So quotient means you divide. And when you divide, we can think about it like this. If I have y to the 6 over y squared, if you expand the y's, then you would have y times y times y 6 times, right? And then divided by y squared, so 2 y's. Let's think about canceling. So one of these y's would cancel with 1 up here. One of these y's would cancel with 1 up here. So how many y's do you have left in the numerator? So y to the 4th over 1, or just y to the 4th. So the way we do that, if you do a shortcut, is you're subtracting. So you know how if you have y to the 6 times y squared, then you add, so that's y to the 8th. If you divide, then you subtract the exponents, as long as the bases are the same. So you can think about it as subtracting the exponents or canceling out the variables. I like to think about it as canceling instead of subtracting, especially when we get into negative exponents when you come back from break. So a couple more examples. So number 1, 8 to the 10th over 8 to the 4th. So 4 of these 8s would subtract from 4 up here, leaving 6 left over. So 8 to the 6th. Here, the base is negative 3, so you keep the base the same and subtract the exponent, so that'd be negative 3 to the 6th. And since the exponent is even, we can get rid of the negative sign when we get rid of the parentheses, so positive 3 to the 6th. Number 3 has a combination of adding and subtracting. So first, let's add the exponents in the numerator. So that would be 5 to the 12th over 5 to the 7th. And then you would subtract since they're dividing, so 5 to the 5th. Okay, number 4. The way this works is just like any other fraction times a whole number, you can combine them if you put the whole number over 1. So that would be x to the 6th over x to the 4th if you multiply across, like 1 times this, and then x to the 4th times 1. So you can write it as one fraction and then subtract the exponents. So that would end up being x squared. Does that make sense?
Yeah, it does.
Just put your whole number over 1 and multiply it across, and then you can cancel out.
How did we get x or
Why did we
x power?
Oh wait, we are.
Oh boy! How did we get that over top?
Okay, you know how we have a fraction times a whole number, like not a fraction? You could put the whole number over 1 to make it a fraction, and then you multiply across. Like multiply the numerators together, multiply the denominators together. And then you can subtract the exponents. Okay. You want to try number 5? What would number 5 be? Grant? Grant? Did you want to answer it? No? Matthew?
No.
Is it just a positive?
Interesting.
Positive?
No. Wait. Is it -2?
Yeah, it's -2. It'd be -2 to the first, which is just -2. Okay, how about number 6? What is number 6? Emily? Yes, good. R to the third. So you have whole number exponent divided by a denominator exponent. All right, do the try it questions. I'll give you 30 seconds. Shh. You already did this. All right, A, you must be done. Eliana. Good job. And then B. Here. Jack J.
-4.
4 to the 7th. Good job. And then C. Amazon here. Avery. Good job. And then D. Oliver. Good job. I feel like we just did that one. This is the same thing as number 6. All right. Now we're going to keep going with 7.2. So if you flip your page over. All right. So next is power of a quotient. So on accident, you guys kind of already learned how to do this. It's just the same thing as if you have a power of a product. You just have to raise everything in the fraction to that exponent. So for example, 3 to the 7th, you do 3 to the 7th over 2 to the 7th. I'm just going to leave it like that because 3 to the 7th is too big of a number. We could figure out 2 to the 7th, but 3 to the 7th is a little too high. So just leave it like that. What? No, it would not. It would not simplify to 3 over 2. No. Because, like, let's say you had, well, or would it? If you had 3 to the 3rd, that'd be 27. 27 over 8. Is 27 and 8 divisible by each other? No. 9 over 4 is not divisible by each other. So, no, that doesn't work like that. Good question, though. All right. So, number 1 would just be x to the 3rd over y to the 3rd. Number 2, since it's being squared, the negative sign is going to go away. 7 squared is 49 over x squared. Number 3, there's a negative in the parentheses, but the exponent is even again, so the negative is going to go away. 2 to the 4th is 16. So 16 over y squared. Y to the 4th, yep, sorry. And then number 4. 4 to the third, anything that's a cube, you can look up there at the perfect cubes. So that goes 1 cubed, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and so on. So 4 cubed is 64. So 64 x to the 6th power, because you multiplied the exponents, over 125 y to the 3rd power. Okay, then we get a little more complicated. So number 5, we're just going to focus on the parentheses first, like raising everything to the 7th power. So x to the 3rd raised to the 7th power would be x to the 21st over y to the 7th. And then times 1 over 3x to the 8th. Okay, now I'm going to multiply the fractions across. So x to the 21st over, and then when you write numbers and variables, write the coefficient first, and then write the variables in alphabetical order. So I meant to say 21st. So x to the 8th, and then y to the 7th. What would we do next? Jack?
Subtract x to the 22nd or 21st by x to the 8th.
Yes, anytime you have two variables in an expression, you have to combine them. So here we're going to subtract. So 8 of these x's are going to cancel with 8 up here and leave you with how many left over? 13. So your final answer is going to look like x to the 13th over 3y to the 7th. There are no more x's in the denominator now because they all canceled out with the ones in the numerator. Got it?
Actually, if you add a line to y, it becomes x.
Okay, let me give you a second to try 6. I'll give you a head start. You can check your answer when you're done. Did you get it?
Yeah.
Oh, I got it.
Yeah, I can't believe it might have been on visibility.
Hi, YouTube.
You got it wrong?
I got it wrong.
What'd you get wrong?
How is it not 8?
Listen,
How is it 8?
how is it a to the 8th? Because you have a to the 10th, and then you have a squared. So 10 minus 2 is 8. Did you try to add them or divide?
I have no idea what I did.
Okay.
Matthew doesn't understand.
All right, do the you try questions. You got 1 minute.
What'd you get?
Jack, you took my calc.
You don't need a calculator.
I don't know what he's using it for.
No, you don't.
Yeah, on the D.
No, you do not need a calculator. No, put it away. No,
What is it?
no calculators allowed.
Yeah, they're banned, bud.
Yes,
But I
you.
paid for it.
27 times 16.
You're overthinking.
Why? I moved the T
I'll
up
I'll
now.
I'll show you in a second.
Yeah, like Jack. Like,
That boy.
get off
Wait,
Jack
that
first.
boy.
Okay. Let me call A through C, and then I'll show you guys a trick for D. So Joey, what did you get for A? Good job. And then B, what'd you get for B? Grant.
Negative 5 thirds over, wait, no. Negative 5 to the power 3 over 5 to the power 3.
Yeah, I'm gonna go ahead and say that that's 125 though, because I know 5 cubed is 125. And then C, Jude. Yes, sorry. I keep forgetting to say which Jude. No. Grant, turn it on. Yes, good job.
How you all not get that? That's exactly. How do y'all not?
All right, part D. Okay, so let me simplify the first expression. That would be 8s to the third over 27 t to the third times t to the fifth over 16. Let me show you a way you can do this without a calculator. Do you see the 8 and the 16? We can simplify that to be 1/2. And the t's, we have t to the fifth up here, t to the third down here. These 3 t's will cancel with 3 up here and leave you with 2 left over. That's how I like to simplify when I've got like a variable over here and then 1 down here. Yes, because 5 minus 3 is 2. We're dividing because 1 is up in the numerator. Wait. T to the third.
So
3 to the third is 27. T to the third is t to the third.
So it's just.
Okay, now I'm going to combine them. So in the numerator, we have an s to the third and a t squared. And the denominator, we have 27 times 2, which is 54. Well, we have the 27 here, though. So we have to multiply 27 by 2 because that's what's left over in the denominator.
Why did you do about 1/2?
I need a calculator.
Because it's not one, it's in, everything's in the denominator, you multiply the denominator together. Yeah. Okay, next we're going to do the word problem and then the exit ticket. Shh. The order of magnitude of the luminosity of the sun is 10 to the 26 watts. The order of magnitude of the luminosity of Canopus is 10 to the 30th watts. That must be some star or something.
Yeah.
How many more times more luminous is Canopus than the sun? Abel, what'd you say? Yeah, 10 to the 4th. So in this case, you can think about it as dividing them. So 10 to the 4th watts. Wait, there's an exit ticket. All right. There's your exit ticket. Simplify those 3 problems. Just at the bottom of your notes is fine.
Miss Billy?
Shh.